Assalamualaikum, we are from Group 8. Today, our group will present about our project with a title of Analysis on BMX Bicycle Frame. Our group consists of 5 members, which is Nurul Wahidah binti Rohaimi, Nur Aisyah Balkis binti Muhammad, Nur Jihan binti Rosman, Nur Shamimi binti Hamdan, and lastly, Saiful Fahmi Azim bin Azmi. And we are from Section 3. As introduction, I will tell you about our background study. During this pandemic COVID-19, cycling has become a trend where we can see that lots of people make this as their new hobby to stay fit when restriction movement order apply. As we all know, it is very important for a frame or a body of a bike to have a strong and high durability body, because the frame is not only to hold the entire bicycle, but it also needs to consider the weight of the cyclist and the impact from the uneven condition of the road when riding it. Plus, each design has their own limits of load that it can hold. So, in this paper, we will study and analyze a frame of BMX bicycle with size of Pro SL. To analyze the design, we use finite element analysis method by using ANSYS Workbench software. What is FEA? FEA is stand for finite element analysis. These are usually a method used by designer to verify the limit of force or pressure that are allowed to be applied. By applying this method, we can know the maximum limit of our design or the minimum limit of our design and can make modification or improvement uh, for the performance of the bike. So, by this, we can ensure the safety of the users and make sure the frame or the body can sustain in all conditions.
A bicycle manufacturing company is currently in progress to design a new BMX bicycle equipped with several sizes for consumer. Before they proceed to manufacture the design, they need to test the bicycle frame structure using ANSYS Workbench module to confirm that the product will work as it's supposed to, or if it needs refinement. This is an essential step as a safety measure before the product reaches the consumer. Thus, testing the design using ANSYS allows the designer to assess the viability of a design created.
Next, the objective of this project is to analyze the finite element method on a bicycle frame problem, which is in three-dimensional space, which is x-axis, y-axis, and z-axis. According to the specifications on top tube, chainstay length, bottom bracket height, chainstay angle, heat tube size, standover height, and the last one is wheelbase. So in this project, we'll be using ANSYS Workbench module instead of ANSYS PDL. So next, another objective of this project is also to determine the deformations in terms of the directional deformation and total deformation, stress, which includes the direct stress, maximum combined stress and minimum combined stress, and total bending moment for the whole body. And the last one is the total bending moment for the respective of the beam that we have selected, which is upper front of the frame, lower front of the frame, and the center tube of the frame, using the respective internal and external forces applied on the frame. Lastly, we will also analyze the effect of the different magnitude of the force applied on the frame and different frame tube size according to the diameter. And therefore, to achieve all these objectives, we have divided our case study into 5 sets, which is set A, set B, set C, set D, and set E. And each member will have their own frame specifications in terms of diameter and the length for each of the beam of the frame and the magnitude of the force applied to the body of the bicycle.
In this report, we have analyzed 5 different case studies. The first one is from Nur Wahida, which is about the basic requirements stated in our problem for this project, where the diameter of whole body is said to be constant. The magnitude of force applied at the seat post is 600 Newton, and the vertical 200 Newton is applied to the pedal crank. The second case study is from Nur Jihan. The design is a little bit different from the basic structure where the joining at the seat tube is a bit lower. Then, the magnitude of the applied force at the seat is also increased to 700 Newton. The third case by Shamimi. The joining at the seat tube is lowered and the applied force at the pedal is increased to be 300 Newton. Case 4 by Balkis, there are some changes in coordinates and the seat trace is located higher than the top tube. And last one is case 5 by Fahmi. Force is the same as written in the report, which is 600 Newton and 200 Newton. There are 4 types of cross-section involved and the joining at the seat tube is connected to the seat tray. After doing some analysis on ANSYS, it is found that most of our cases have the critical point at the seat post. For example, in case 5, the center tube of the bike has the highest bending moment at the length of 0.3219, in which is 10.442 Newton, same as the value in total bending moment analysis. Therefore, it is proven that this part is the critical point which have highest potential to break. Based on this analysis for this design, in order to have a better performance and higher in strength to withstand higher force applied, we can make some modifications. First, we can change the type of material used with higher durability than aluminum, or use mixture of metals to get better performance. Next, the designer can also increase the thickness of the tube, which can hold higher impacts.
For the conclusion, a few cases have been made to analyze the finite element method on a bicycle frame problem, which is a three-dimensional space using ANSYS workbench module. The deformation, stress, and bending moment of the frame analysis will be obtained after an external and internal forces are applied on the body. A few changes have been made on the bicycle frame in terms of the thickness, the value of force applied, and the joint of the nodes. After we analyzing all of the cases, we can conclude that the center tube of the bicycle frame has the highest bending moment and the most likely to break compared to the other tube. Most of the cases has critical point at that point where the seat and the tube been attached, even when different values of force thickness and fits are applied. A few modifications can be made to improve the structural body of the bicycle frame to prevent the frame from bending and break. One of the modification that can be done is to change the material to something that is more stronger and has higher durability than the current material, which in our case the current material is aluminum. So we can change the material from aluminum to something that is more stronger. The thickness of the tube and the dimension of each tube need to be changed to make sure that the body can support the force applied on the body and improve the performance of the body.